This is a mechanical energy storage system, a flywheel, a spinning mass inside this cylinder right here. Turns out in our move to wind and solar, we lost something critical: inertia in the grid. Coal, gas, hydroelectric turbines, enormous rotating masses, some weighing hundreds of tons. Solar panels and wind turbines don't produce power this way. This could help solve that, but it gets even cooler because this model right here has a superconducting crystal bearing, which means that over the course of an hour, only 0.1% of the energy inside here is lost. So we flew out to the Netherlands to meet with a company called QuinteQ, because this story has it all, from Boeing patents, from space systems, all the way to ultimately their design that will meet customers. But we'll talk about the system, the flywheel, all the engineering, and get to the bottom of why this could be a game changer for the future of sustainable energy. I'm Ricky, this is Tuba Da Vinci.
This video is brought to you by QuinteQ.
Spain, April 28th, 2025. It was a normal day. Solar was generating roughly 60% of the country's electricity. Then a small electrical oscillation at a photovoltaic plant cascaded into catastrophe. 15 gigawatts of generation gone in just 5 seconds, and tens of millions of people across Spain and Portugal plunged into darkness for nearly 10 hours. The cause wasn't that solar failed. Solar was working perfectly. The problem was that the grid had no shock absorbers left, no heavy spinning metal to dampen the oscillation before it spiraled out of control. The UK learned this lesson the hard way too, after their own blackout in 2019. Their response? They invested £328 million into flywheels and synchronous compensator projects. 11 are now operational across Britain. One facility in Liverpool, Statkraft's Greener Grid Park, has two 40-ton flywheels that provide roughly 1% of the entire grid inertia for England, Scotland, and Wales from just 2 machines. So flywheels aren't theoretical, they're already saving grids. But one of the most fascinating flywheel stories I've ever come across is the one happening here at QuinteQ.
I used to live and work in San Francisco, and one of the things I was working on was a small vertical axis wind turbine. I was able to bring that together in a partnership with the Boeing company. You had all these great scientists that would then basically review the design, the original IP, and then see how they could adapt it. And then the last stop we went through was the radar expert. And he's like, okay, this we cannot do, because the radar profile of these small wind turbines was so profound that any hostile actor would just have to go on a very simple rudimentary radar, and you could pinpoint exactly where the American camp would be. I was walking away from that meeting over the parking lot to catch a plane back to San Francisco, and somebody ran after me and tipped me on the shoulders and said, "Hey, are you Paul Hosbeek?" I say, "Yes, I am." "Well, do you still have time?"
Boeing invited Paul into a secret lab. In the 1980s, President Reagan launched a strategic defense initiative nicknamed Star Wars. The idea was ambitious and a little insane: put lasers in space that could shoot down incoming nuclear missiles. The problem was power. Lasers need enormous amounts of energy, and they need it instantly. Boeing's Phantom Works division had the answer: flywheels. Spin a composite rotor to incredible speeds, store energy as kinetic motion, then dump it all at once to power the laser. But the breakthrough wasn't the wheel itself, it's how they made them float. Boeing used a material called YBCO. That stands for yttrium barium copper oxide. And when you cool it down to about 60 to 80 Kelvin, which is liquid nitrogen temperatures, it does something remarkable. It becomes a superconductor, and it exhibits a property called flux pinning. So if you place a magnet above it, the magnet doesn't just float, it locks the position in 3-dimensional space. When you use this as a bearing for a flywheel rotor, the result is extraordinary. No contact between the rotor and anything else, no friction, no wear, no maintenance. You could store energy for hours, not minutes. Boeing had built a nearly frictionless spinning battery, powered by frozen crystals. But when the Strategic Defense Initiative was canceled, the government funding dried up.
Boeing asked me if I was going to be interested to take over that IP. About a year and a half later, we got the contracts. We got a worldwide exclusive license for 200 patents, and that was the start of QuinteQ.
This is the kind of amazing engineering that keeps me up at night. And something else that keeps me up at night is protecting my personal information online, and why I'm a huge fan of our sponsor this week, QuinteQ. Information, your home address, phone numbers, even your relatives' details, is being collected and sold online. It's not only lucrative, but totally legal. And this valuable data advertisers crave is the same data criminals use for everything from scam calls to identity theft and actual stalking. I signed up with QuinteQ because they work nonstop to constantly look for your personal information online and automatically request to have it removed. This is something that would take you and I hours, and it's not a one-time thing, it's an ongoing battle. If you give Incogni permission to act on your behalf, they go to work contacting hundreds of data brokers to get your data taken down. What really sold me was their custom removals feature. If you find your info on some random website, you just send Incogni the link, and their team handles getting it removed. I love the internet, but we have to be real about some of the dangers, and companies having access to your personal information is one of them. So if you've been thinking about staying safe online and want to take back control of your personal information, go to incogni.com/2bit to get 60% off an annual plan today. Huge thanks to Incogni and you. Now back to the show.
So this is it, the QuinteQ Flywheel. And the first thing that strikes you is how compact it is. It fits in a standard 10-foot shipping container. It weighs around 6 tons and it can deliver 300 kilowatts of power. That might not sound like a lot until you realize the thing can dump its entire energy reserve in seconds and recharge just as quickly. Over and over more than 350,000 times without degradation like a traditional battery. The physics of why this works are actually pretty elegant.
So you probably know a pottery wheel. Pottery wheel, you basically turn with your feet, and you're not gonna stop it with your hands because you know it's gonna hurt. There's energy in there. Flywheel. So let's suppose you put this in magnetic bearings, so it levitates like a maglev train in Japan or something like that. That means there's no friction here, which means that any energy in there, it will keep turning, but it still has drag, you know, like a car, for instance. Then you put a vessel around it and you take the air out, so it's in vacuum. So basically once it spins, it stays spinning forever. Now the big problem is now your feet can't reach it anymore. So how the hell you're gonna drive it? You stick on some magnets on the shaft. Here you put some coils, which means then you made an electromotor or motor generator.
The energy stored in a flywheel is defined by a simple equation. 1/2 times the moment of inertia times the angular velocity squared. You see that squared? That is the cheat code. If you double mass, you double energy. But if you double speed, you get 4 times the energy in the same footprint. That's why QuinteQ doesn't use heavy steel rotors like the old gyrobuses in the 1950s. They use carbon fiber. It's lighter, but it has immense tensile strength. Their rotor spins at speeds where the rim is moving at Mach 3, nearly 1,000 meters per second. And if you're wondering why it doesn't just burn up, it's because the whole thing operates in a vacuum. Now, obviously, there's a lot to love about mechanical flywheels. As a mechanical engineer, I just find them fascinating in a way that chemical batteries just aren't. But I think one thing we can all agree on is that superconducting crystal bearings are just super cool. That's why I wanted to come here and ask him about it. And after meeting with the team, what I learned is not what I was expecting.
Obviously, the uniqueness of that Boeing flywheel was it was ultra efficient, right? So it had standby losses inside of the can of less than 0.1% per hour.
Which is crazy for
Which
a
is
flywheel.
crazy.
QuinteQ spent years working on the superconducting bearing system, and they actually got it to work. They proved the physics, they published papers. They had a flywheel that floated on frozen crystals with almost zero friction. And then they completely got rid of it altogether.
We ended up building one. We got it exactly as Boeing had it designed, with the superconductive bearing, with the carbon fiber rotors. And in that process, we also found out that this ultra high-tech aerospace engineering foundation that we took over from Boeing was not necessarily a good fit with these earthy applications like construction cranes or port cranes or anything else. So we ended up really, we hacked the Boeing IP to turn it into something that is more reliable, but mainly also much cheaper.
Those YBCO crystals are manufactured in specialized laboratories. They're expensive. And to keep them superconducting, you got to maintain cryogenic temperatures of 60 to 80 Kelvin inside every shipping container that you deploy. And when they added it all up, they came to a startling realization that this was the most elegant possible solution to a problem, but that it wasn't the right solution. So they had to make a hard call. They switched to active electromagnetic bearings.
The trade-off would be you can, instead of having the superconducting crystal bearing, which gives you the 0.1% energy loss per hour, which is insane. But if I'm operating a crane 5 times an hour, that's never going to be a problem, right?
Never a problem.
So you trade that potentially
for cost. Because,
Exactly.
and it sounds like power also. That's interesting.
Cost, power, output, footprint, and all these things that are important for our end market, for our end users, is what we incorporated into this redesign. And this is now the QuinteQ, the new kid on the block.
Do they have more friction? Yeah, slightly. Do the flywheels lose energy a bit faster? Yes, they will. But the electromagnetic bearings are dramatically cheaper, dramatically simpler, and they're commercially off-the-shelf available. And the product went from a lab demonstration to something actually sitting on a dock in Rotterdam, actually saving companies money and actually doing real work. This was around the point where on this trip I realized that maybe we need to think about sustainable energy technology a little bit differently. Because QuinteQ's story isn't unique. Take SunPower. They make the most efficient residential solar panels in the world. They charge $3 to $4 per watt installed. Meanwhile, Chinese manufacturers were building panels 22 to 24% efficient, almost as good, for less than $1 per watt. In August 2024, SunPower filed for Chapter 11 bankruptcy. As amazing and cutting edge as their technology was, it just didn't meet the market expectations and didn't deliver on price. QuinteQ lived this. They had the objective superior bearing technology, superconductors that defy physics, and they chose to walk away from it because the slightly worse solution was 10 times more deployable. But does it actually work in the real world?
What this thing is strong at is delivering power peaks over and over and over, because it doesn't degrade over time. It has hundreds of thousands of cycles in it. So we've been looking at what kind of applications do we see that has this type of behavior. And we figured out that cranes in particular, on a construction site, tower cranes, or in port cranes, they have these very high power peaks.
Think about what a port crane does. It sits idle. Then a container ship arrives and suddenly it needs hundreds of kilowatts, sometimes megawatts of power to hoist a 30-ton container. It does this for a few seconds. Then it goes idle again. Then another lift. All day long, massive, violent spikes that are absolutely brutal for the grid.
Constructions can't get their grid connection anymore because of grid congestion. Their power demand is going through the roof. And they have to make do with the infrastructure that's there, or spend a lot of money on upgrading it. And what we do with the Flywheel, we install a container there, we can peak shave multiple cranes, and we bring down the power demand by 60 to 80%. Instead of needing 5 megawatts of power, maybe you now only need 1 megawatt. When it's going down also, that's the interesting thing. Especially port cranes, tower cranes don't have that much, because the tower crane only lift up heavy load to the top and then empty below. But a crane goes heavy up, heavy down. When it goes down, it generates energy. You're sending energy back to the grid. The fun thing about this one is that you can capture that energy actually and reuse it on the next hoist.
At the Steinweg terminal at the Port of Moerdijk in 2025, they did 70% peak power reduction. The system responded in fractions of a second. It also compensated for reactive power and improved voltage stability across the terminal.
We have traction not only here in the Netherlands, but we are working on projects in Denmark, in Spain. We have clients lined up in Italy. We're also going to be deploying systems in the United States pretty soon. I just came back from Kiev, Ukraine, where we have a contract to deploy a total of 6 of these flywheel systems to Port of Odessa to help keep that port operational even when the central grid is under attack and is dysfunctioning.
QuinteQ pairs their flywheels with sodium-ion batteries in their Zeus hybrid container system. This flywheel handles the violent power spikes. The battery handles the sustained load. Each technology does what it does best. And QuinteQ isn't alone in this space. Taurus, based in Utah, just raised $200 million and has deployed over 230 flywheel systems for airports, ski resorts, and data centers. Amber Kinetics, a UC Berkeley spinoff, Go Bears, has partnered with Kawasaki Heavy Industries to pair their 4-hour flywheels with virtual synchronous generator technology software. At this point, it's time for a bit of a reality check, right? When we talk about these technologies, it's never one or the other. It's not that flywheels are going to replace batteries or anything like that. It's quite the opposite. Remember that flywheels are sprinters, not marathoners. High power, low energy, niche applications built for specific purposes. I think the port crane is the best example I've heard of so far. But that niche is growing fast. Every coal plant we're retiring removes shock absorbers from our grids. Every data center we build adds another power-hungry consumer that demands instant, reliable energy. Every port we electrify needs burst power that batteries alone probably can't deliver. The most important thing I've learned visiting QuinteQ wasn't about flywheels per se, although I did learn a lot. It's about the next chapter of clean energy. As an engineer, I love a good story, the technical challenges and the details that make something interesting. Superconducting crystal bearings. I mean, come on, that just sounds amazing. But what I've been learning, the more I do these videos and cover more and more companies doing this, is ultimately you got to win out on the economics. The business side has to win out too. You got to be able to make these cheap enough. Manufacturing has to come into play, supply chains, and all the rest. It reminds me of this amazing quote from Darwin. It's not the strongest of species that survive, nor the most intelligent, but the one is most adaptable to change. And that tells this story perfectly, because this captures how this idea started from a Boeing patent, from space systems, to ultimately what customers actually need for the grid. I love mechanical energy storage. I think flywheels are some of the coolest things. As a mechanical engineer, I have a special place in my heart. But what do you think? How big of a role will flywheel energy storage have to the future of more stable grids? Sound off in the comments below. And until next week, check out this video that we think you'll also like. I'm QuinteQ Vinci. Thank you so much for watching.